now quickly move on. Once you have read the chain rule, we have to see now what exactly is backpropagation algorithm. There is a prerequisite called chain rule for this particular topic. Please understand that, then only you will understand this algorithm. Now, coming to backpropagation algorithm, backpropagation is actually a short form for backward propagation of errors, which I already taught you in my last class. Okay, it is an algorithm which is used for optimization, that is to reduce our loss function. So it is an algorithm used to train artificial neural network, including the deep learning models, and it is a key component of the training process, which is responsible for updating models' weights to minimize the error between predicted value and the actual value. And thus it is a very powerful optimization algorithm that I can say, which also uses gradient descent into it. Okay, now we are going to see how step by step we will be understanding how to apply our backpropagation algorithm. The very first thing is, whenever you are starting your neuron model, you have to initialize with your weights and biases randomly, okay, on any random value. We prefer to give bias as 0 and weights will be randomly taken and initialized. Once you initialize your weights and biases, what are you going to do is, you are going to apply the forward pass. Now this input data that is given is fed forward throughout the network layer from the input layer across the output layer, and for every layer in between you would be calculating your linear function, that is sum of weighted sum of inputs of each neuron in the layer. Once you get that linear function of summation, you will be simply applying the activation function to it. Okay, we have been doing this, right? So you get a linear combination, you will apply an activation function in order to get the predicted output. So I can say that, you are using an input function x, you are applying to the first layer activation function that serves as an input to the next layer, get a linear function, apply activation layer, serves as an output, give that as an input to the last layer, and then finally you get your predicted output. I hope forward pass is clear here. Now once you have done with the forward pass, what are you supposed to do is very simple. You will be calculating the loss function. Once you have got what is predicted, that is your y cap, you always try to have a difference between your predicted value and the actual value which is present over here, and you will calculate the loss function. If you are choosing regression, use MSE loss function, mean squared error. If you are choosing classification, go for cross entropy loss function, and you calculate your respective loss function, generally denoted as L or E in some textbooks. Okay. So now once you have done with loss function, now here you have to apply optimization algorithm like backpropagation. So what do you do exactly now? Once you have done forward pass and computed the loss, you will go for backward pass, which is backpropagation. So what you would do here is, you would compute the gradient of your loss function which you determine with respect to the output layer's inputs. So what you will find out dou loss by dou output layer inputs and dou loss by dou weights and dou loss by dou biases for each and every layer, and this is the place where you are going to use the chain rule which I just taught before in the previous topic. Okay, so you will try to find out this dou loss by dou output layer input, which helps you to propagate this gradient backward throughout the network. You will calculate the gradient of the loss with respect to weights and biases of every layer. So this is what you are going to do basically. So let's see and understand this more clearly. So you all know that I would choose a gradient descent algorithm here to calculate, the gradient of my weights. So you all know there's a learning rate. In some textbooks it will be like eta. Okay, here I have chosen as alpha. Anything is okay. And E can also be replaced as a loss function L. It's up to you. Here I have chosen E as an error. You can choose as L also for loss function. Anything is okay. And gradient descent algorithm means you calculate loss function and you want to update your new weights and bias. For that you will use gradient descent algorithm, where new weight will be old weight minus, it can be eta. Eta is your learning rate or alpha is your learning rate, and this is your nabla, which is your rate of derivation of error function or loss function with respect to weights. Okay, so if you are updating weight, you will choose like this. If you are choosing bias, you will write new bias is equal to old bias minus alpha dou E by dou B. So you will try to update your weights and biases here. Once you have done that, you keep on updating, calculate again forward pass, calculate again loss function, check if it is decreased or not. If it is decreasing, keep on iterating it for a fixed number of iterations that we call as epochs, unless and until it comes to a minimum value of satisfaction. Once you are done with that, you please evaluate the model, and then after training, you evaluate the model's performance on a separate validation data set. And to assess its generalization ability. Okay, once you have evaluated and trained this particular model, it can be used for whatever purpose or application that you have chosen for. So this is basically an entire step-by-step procedure where you will use backpropagation algorithm to get an optimized model. I am really hoping you have understood this. And then what you are going to do next is, I am showing here one simple example. I just explained you backpropagation, how it works. For an example, here I have chosen a multi-layer perceptron wherein I have taken here 3 inputs. Already I have showed you how you are going to use these the layer superscripts and the subscripts format, okay, where to use output and input. So you can see here I have chosen here 4-layer multi-layer perceptron. So I guess forward pass is very simple. Suppose I want to go for a backward pass wherein I want to calculate this particular part, okay, wherein I want to calculate edge of 1,3 superscript with 1. So what am I going to do? First I will calculate the forward pass. I move forward, I move forward, I move forward, and I calculated something. Now once I got an error or a loss function out of it, now I'll move back. So what I'll calculate now? First, 4th layer. So I'll calculate penultimate layers now. Dou E by dou W of 4th layer, and I'm going to calculate 2,1. Once I am done here, I am moving in this direction again. So for the next one, I will calculate dou E by dou W of 3rd layer and say 2,2. Okay, and then next I will calculate dou E by dou W, now 2nd layer, 3rd and 3,2. Okay, and then finally I will calculate dou E by dou W of the 1st layer with respect to 1,3. So you can see here very beautifully. Now I can use the chain rule wherein the first derivative, first layer from the back side, penultimate layer, okay, and then you have got second derivative multiplied with third one, and this. So you can see nested derivatives here. Very beautifully you have used chain rule, and very simply you have calculated entire gradient of this particular node. Now you will use this gradient, you will try to update new weight associated with that node as old weight minus learning rate into this particular gradient that you have just calculated, and you will update the weight and bias of this particular node. I hope the process is clear. So the error back propagated is effect of error on edge 4 into effect of edge 3 into effect of edge 2 into effect on target. So this is how chain rule wonderfully helps us to calculate gradient very simply, which in turn will help you to apply gradient descent algorithm and get updated values of weights and biases. You keep on updating it for several epochs or iterations unless and until you are satisfied with the minimum error or minimum loss function that you are getting, and then you will say that this is your optimized model and you will stop it. So that's how an entire backward propagation optimization works. I hope you're all clear with this. So to understand this particular thing, first I request you to understand chain rule and then come back to this. With this we have finished our backpropagation algorithm.